A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. I had asked you guys a question that why is it that global warming is leading to increased occurrence of cyclones? May I have the answers, please, if at all? Pranay, due to global warming, melting of ice lead to low albedo can cause tropical cyclone. Okay. Any other reason that we can conjure up, that we can come up with? Why is it that due to global warming we have increased occurrence of tropical cyclones is what we are talking about? As simple as that. Satyanarayan, perfect. Nikhil, correct. Basically, rising temperature. Rising temperature means, right, there will be, due to global warming, there is a rising temperature, increased heating. Increased heating means that low pressure areas will get created much more prominently, much more strongly as well, and they will be spreading over to the temperate regions of the world as well. Okay, so Satyanarayan, Nikhil, Himadri, Shilpa, Eman, Benjita, all of you are correct in this. So, Pranay, understand what you are talking about the melting of ice leading to a distortion in the oceanic circulation. Basically, you are talking about the occurrence of cyclones in the region to the northern Atlantic, right? But when we talk about general global warming, is what? Warming of the planet. Warming of the planet means what? The oceanic temperature will also get warmed up and heated up. And whenever the oceanic temperature increases anywhere beyond 27, 28 to 30 degrees, immediately it will lead to occurrence of that low pressure. And that low pressure can get intensified and lead to the occurrence of tropical cyclones. Okay? So that means the concept is clear. Now, we come to the associated concepts. So we start with the storm surges. What do we understand by a storm surge? So what happens to pressure in the eye, Eman, in the case of a storm? In the case of a cyclonic storm that you're talking about, in that case, at the region of the eye, in the upper level, you have a higher pressure. But by the time that it reaches the lower level, that is where you will have the heating, and that heating will be further exaggerated by the sinking air. So, in some localized areas, you have the high pressure, but overall in the larger region, it is a region of a low pressure. Okay. Now, we come to the portion of storm surge. So, the name in itself tells you it is a surge. Surge means a sudden increase. So, whenever a tropical cyclone is observed, immediately you have coastal flooding, which becomes a commonality, which becomes a common factor, right? Almost all the areas where the tropical cyclones end up influencing and hitting, those areas, they get impacted by the coastal flooding. Now, why does that happen? So, part of it is because of the phenomena that we refer to it as storm surge. Now, what is a storm surge? Storm basically refers to stormy conditions, refer to when you have the wind speed which is extraordinarily high, which moves at a very high pace, right? So when you have very strong winds, so that those winds on the surface, they are able to drag along with them substantial amount of water as well. So very strong wind movement, that drags substantial amount of water along with it. And provided and given the fact that already in the region of the eye of the cyclone, the water level is slightly higher, so that dragging of that particular water basically means that the waves, they become much more stronger, and they end up impacting the coastal areas, and the coastal areas experience flooding as the consequence of it. So here, storm surge is an abnormal rise of water generated by a storm over and above the predicted tides and the waves. So, during the cyclone, a cyclone the wind speed is very high. And when the wind speed is very high, it drags the seawater along with it. Okay, so the seawater is dragged along with it. And when the seawater gets dragged along with it, so it will leads to flooding. In the coastal areas. Now, by the way, there is another reason why the coastal areas get flooded. And we have already talked about it, that in the region of the eye, the sea level is slightly raised up. So as the eye comes and hits the land, that raised sea level will bring about flooding. But also, you will observe that in many of the areas, a unique feature where if you think about this, let's suppose, as the land and the ocean or the sea. Now let's assume that here you have a river which is draining into the sea. Let's assume. Now, river water, and try to listen to this very carefully. It is a simple process, purely applicable by logic. So try to understand this. So here, during the case of a cyclone, in that region you have extensive low pressure, sea level rises slightly upwards. So here, let's suppose in this area, the sea level rises slightly upwards. Rise in sea level due to intense low pressure. Now, if the sea level rises, think about it. The river water was exiting into the sea, but the sea level has risen up. So that means what? It basically means that the river water cannot empty itself again into the sea. The river water will be restricted, because if something is flowing and you put an obstruction in front of it, here you have a kind of a water wall, so it cannot empty into the sea anymore. So rather than flowing into the sea, even for the briefest of the moments, even for a couple of hours, if this condition exists, all that water will start to spill over. All that water of the river will spill over. And that also leads to flooding across the coastal areas and in the coastlines where the rivers are in existence. So that tells you that these storms, basically, whenever you have the cyclonic storms, even the rivers will flood. Rivers will flood not only across the coastline, but it might flood maybe a few kilometers in the interior as well. Why? Because the flow of the river is immediately put a halt to. And plus, you have the wind motion bringing that excess water, plus, you have that overflow. So, all these factors add on together, and that leads to devastation at an unparalleled scale and an unparalleled level, especially across the coastline. Okay? Now, after this, we come to the portion which again has been asked in the civil services multiple times about the naming of the cyclones. How is it that the cyclones are named? What is the process of naming of cyclones? So basically, before we talk about the naming in itself, let me give you a brief preview about it or a brief background about it. That when is it that this process was initiated? What was the process? And why is it that the naming was initiated? First of all, before also, when the cyclones would occur, before that entire naming thing came into prominence, cyclones would always be designated a particular name, scientific name, based upon certain alphabets and certain digits, only for the reference of the climatologist and the meteorologist. But everything changed in 1999. Now, I'm sure in 1999, many of you would not even have been born. Many of you would be so very young that you wouldn't recollect anything which happened at that point of time. But in 1999, a massive super cyclone hit the Odisha coastline. Now, if you think about the efficiency of administration nowadays, obviously government machinery is not the most efficient one. So you can always put your estimate that what the government machinery would be or what it would have been like in 1999. Obviously, we did not have digital communication. We did not have methods or means of certain mass announcement and mass communication. Disaster management was absolutely abysmal. So, our disaster management ability was absolutely very, very poor, very bad when you think about of 1999. The government, on its part, in the later stages, before the cyclone was about to come, it made an appeal. It started announcing and told people to evacuate their homes. But think about it. When someone from the government comes to your house and tells you, evacuate your house, what is the first feeling that you have? The first feeling is that of hesitancy, some amount of hesitation, right? You eye it with suspicion. That why is it that they are asking us to vacate our house? Maybe they want us to vacate and they will occupy this house on their own. So people generally nowadays they agree or nowadays they listen to these commands and these particular instructions because they know that they mean business. The government officials, they are serious, etc. But way back in 1999, the trust level obviously was very low. So people did not evacuate. Few of them did, but majority of them did not evacuate, owing to the last minute announcements, etc. A super cyclone hit the Odisha coastline. Super cyclone means wind speeds higher than 220 km per hour. Now, that meant a lot of destruction and devastation across the Odisha coastline. Those of you belonging from the state of Odisha, if you ask your elder generation, be it your parents, your grandparents, they would basically recall it with a significant degree of sadness about what unfolded at that point of time. Nonetheless, when that super cyclone hit, the destruction caused was widespread and it was unparalleled. In a situation where you had bodies floating everywhere, the coastlines were flooded, and still people were counting the dead and the lost. They had no account of that. Everybody was in a united fashion, very simple in their agenda that it is the government which has faltered. The government could have done better. They could have made the announcement. In the meanwhile, the Indian Meteorological Department detected the formation of another super cyclone, again scheduled to hit the Odisha coastline within a span of 10 days. Now, this time, they did not lose any chance. This time, immediately, they deployed the people on the ground wherever the people could go. Obviously, a lot of areas were flooded, a lot of areas were so very devastated and destructed, it was almost on the verge of getting depopulated, certain districts, for example. Now, wherever they could go, they made the announcement that a cyclone is about to strike and you need to vacate. Now, many of them basically thought that, look, the cyclone has already come and has gone away. And now these guys are coming with their announcement. That is how delayed they are, right? The general sense of suspicion that you have towards your government, that now these guys are coming for the announcement. The second cyclone did come. The cyclone did hit. And the second cyclone caused devastation and destruction while people were still outside their houses, outside their homes, looking for the dead and the missing. This time, the devastation was exaggerated. Think about it. Nowadays, if you venture around any part of the country, the amount or the number of kacha houses that you have, that is the mud houses that you have, that is something which is very less, isn't it? But around 1999, that is around 20 years back, 24 years back, the number of kacha houses that you had, mud houses that you had, they were significantly larger in proportion. Now, what that meant, the amount of devastation was very high. And unofficial figures point to close to around 15,000 to 20,000 people who lost their lives in these twin cyclones. Later on, When this was analyzed by the larger community, then at that point of time, it was understood that people could not understand the announcement that a cyclone is about to hit. People could not understand it. So then came the genesis of the idea that let's provide the naming of the cyclone. Let's provide the cyclones a name so that when a cyclone is about to hit, we can announce it. The people will also be able to associate or relate with it. And accordingly, we can also recall it at a later point of time that, you had Cyclone Ampan, you had Biparjoy causing this amount of destruction, etc. So it will be good both for scientific studies as well as the most important fact of all, saving people's lives. Now that was the endeavor. And that is when in 2000, you had countries, especially in the region of Northern Indian Ocean, 8 of these countries, they came together, who were getting impacted by the cyclones in Arabian Sea or Bay of Bengal. They came together. Each of them submitted 8 list of names, right? A list of 8 names rather. And thereby, one by one, a name from that combined list, 8 countries giving 8 names. In total, you have 64 names. So overall, you had these 64 names. One by one, a name was picked up from the list and a cyclone was named after that. The last name on that list, on that older list, was Cyclone Ampan. Cyclone Ampan, for those of you who are unaware, after the Odisha cyclone was another super cyclone which hit the Bengal coastline and the region of Bangladesh in the months of April and May 2021. That is when it hit. 2020 rather. That is when it hit. Okay. Now, basically, by the time that the previous list was exhausted, you had again all the countries in the Northern Indian Ocean sitting together under the aegis of World Meteorological Organization and UNSCAP. All of them, they sat together and they basically came ahead with a kind of the new list. This time, you had 13 countries. And 13 countries, they submitted a list of 13 names each. So in total, how many names do you have? 169. Good. So 13 countries listed these 13 names. So now in total, you have 169 names. And that list is being utilized where the countries are arranged in the column. And for each country, you have the 13 names listed. Countries are arranged in an alphabetical order. One by one, a name is picked up from that list. Okay. Now, how does that naming process happen? First of all, you have two important bodies involved. One is the Tropical Cyclone Warning Center. So, for example, right now, everybody is observing that in the region of Arabian Sea, as I told you in the previous session itself, around 9 degree north, 61 degree east, around that region, the Arabian Sea waters, their temperature has increased to somewhere around 30 to 31 degrees Celsius. So it is a high temperature. And that high temperature means there can be and there will be development of the low pressure and can intensify into a tropical cyclone. So that observation, first of all, is made by the TCWC, the Tropical Cyclone Warning Center. For example, this Tropical Cyclone Warning Center is also observing that simultaneously there's a low pressure which is developing in the Bay of Bengal. Maybe 1 week from now, the next weekend when we meet, we might be talking about another cyclone which is developing in the region of Bay of Bengal. Nonetheless, so when this cyclone develops, or when they get an inkling that a cyclone can develop, they convey the message to the regional specialized meteorological centers, right? They are basically responsible for the meteorological activities, prediction of it, understanding, assessment of those meteorological activities, and assessing the extractable information or knowledge from it. So they are basically associated with these RSMCs. They are spread across the world. Across the world, you have 6 different RSMCs. So if you take a look at it, so for example, for the region of Northern Indian Ocean, you have RSMC New Delhi. which is very much in the building where you have the Indian Meteorological Department office. In that building itself, you have RSMC New Delhi. Now, any cyclonic event or activity which happens in the northern Indian Ocean, be it in the Arabian Sea or Bay of Bengal, comes under the aegis of RSMC, right? Then after that, in the southern Indian Ocean, you have the RSMC La Reunion, that is Reunion Island, which is administered by the French Meteorological Agency. Then you have RSMC Nadi, RSMC Honolulu, RSMC. These are regional specialized meteorological centers, RSMC Tokyo and RSMC Miami, right? Responsible for naming of the cyclones in the region of the Atlantic. So, or the hurricanes as they are referred to. So first, the alarm is raised by the TCWC, Tropical Cyclone Warning Center. Then that is forwarded to RSMC. RSMC, after that, once it has understood that yes, indeed there is a cyclone which is getting created, it picks a name from that list, the list which you see on your screen in front of you. So observe this particular list. So here, this all the list that we are talking about, this list that we are talking about of 169 names, that is 169 names. So how is it that the naming is done? So you have the countries arranged in alphabetical order. All are the countries which are impacted by the tropical cyclones which develop in the northern Indian Ocean, right? And they have provided 13 names. So column 1, column 2, like that, it will continue to column 3, column 4, up till column 13. And you have the names which are picked up from the list one by one. For example, Nisarg, then the next one was named Gati, Nivar, Burevi, Tote, Yas, Gulab, Shaheen, Jawad, Asani, Sitrang, then Mandus, Mocha. Once the first column is completed, then the next column, Biparjoy. Remember the last cyclone which occurred in the month of June, that was named as Biparjoy. Then the cyclone which is getting created in the region of Arabian Sea, that will be named as Tej. Tej is the name given by India. So that will be named as Tej. Simultaneously, if there is another cyclone which gets created in Bay of Bengal, it will be named as Hamoon. So you know what the next cyclone will be named as, right? After that, whether a cyclone gets created in Arabian Sea or Bay of Bengal, it will be named as Midili. After that, if a cyclone gets created in Arabian Sea or Bay of Bengal, it will be named as Migjom, right? After that, you have Remal, Asna, and like that, you have these names which are used up. Any name which basically any of the cyclone which has caused maximum amount of devastation or destruction, where a lot of deaths have happened, that name is crossed from the list, never to be used ever again. Okay, so this is the process which is followed for the naming. Is that clear? Is that understood? Good. Very good. Okay. Now, Gaurav, is there all the 169 cyclones are tropical? Yes, yes. This list that you are talking about, that we are talking about, this is only about the northern Indian Ocean, right? Only in the northern Indian Ocean. So a willy occurring in Australia won't be using this list. It is only the northern Indian Ocean. For example, the cyclone which is developing in Arabian Sea, if it follows its predicted path and pattern, it is expected to deviate towards Oman and some portions of Iran. It is not expected to hit India. It might change its course at the last moment, but as of now, it is expected to hit that region. So basically, it is only in the northern Indian Ocean. These are the countries which get impacted by this. So that is why they come together and basically they gave that list. Okay. Why crossed from the list and not to be used again? If there is a cyclone which has caused maximum devastation, a lot of death, right? Then it is crossed from the list in a sense that it will always be a reminder, for example, that this cyclone had created this much devastation. You will not be reusing the name again in order to have that commemoration of that particular disaster and destruction which is caused. Okay, Priya, I hope that is understood. Parshuram, can you please tell last cyclone name? Last cyclone, which from the previous list was Ampan, Amphan, Ampan, which was given by Thailand, right? That was the name. Okay, but not required. Okay, I hope this is clear. So this is where your compared to India, is Australia having higher cyclones? No, it is the northern Indian Ocean which experiences more number of cyclones. Does it mean when the names will be removed, new names will get added to the list? See, understand, Priya, I think you have not understood why and when a name is removed. Suppose a cyclone occurs and that cyclone is named as Midhili. Listen to this carefully. Suppose a cyclone occurs and that is named as Midhili. After that Midhili makes landfall, it has been found out that it has caused lot of destruction, lot of deaths. So then after that, it will be crossed over. So Midhili has already been used. After that, it is being crossed over. In the sense that when the countries, after the entire 169 names have been used, when the countries come back together to submit their names again, they cannot submit the name Midhili again. Okay, because Midhili will be out of utility from then onwards. I hope that is clear. But the new list will be generated after these 169 names are about to end. That is when the new list will be generated. Okay, is that clear now? Okay, good. So the next cyclone, or the cyclone which is getting created in the region of Arabian Sea, that has been named as Tej. And observe the news headlines. Chances are that in the next 10 days, a cyclone is going to get created in the region of Bay of Bengal. Invariably, it will be named as Hamoon. So while the rest of the world and the general public will be wondering about the name, where the name Hamoon came from, you know that it has been provided by Iran. And regardless of a cyclone getting created now, 10 days from now, 15 days from now, 1 month from now, maybe 1 year from now, if the next cyclone occurs after 1 year, it will be named Hamoon. Okay? Now, Chennai also has meteorological center. Do all states, almost all of them. Okay? Now, after this, we move ahead, and here we look at the differences between a tropical and a temperate cyclone that is listed for your utility. So tropical cyclones, they move from east to west due to the impact of easterlies or the trade winds. And temperate cyclones move from west to east due to the impact of westerlies. Then a tropical cyclone has an effect on a comparatively smaller area because it is created in a region of a small low pressure region. Whereas when we talk about a temperate cyclone, its impact is spread over a very large area, a very large region. Velocity of wind in a tropical cyclone is much higher and it is much more damaging. Velocity of air or wind is comparatively slower. Then tropical cyclones forms only on seas, only on water bodies with temperature of 26 to 27 degrees Celsius, and they dissipate upon reaching the land. That is when they vanish, they disappear. Temperate cyclones, on the other hand, can be formed for on both sea and land. A tropical cyclone, generally from the time of its formation to the time of it hitting the land, won't last for more than 7 days. Whereas when we talk about a temperate cyclones can last for 15 to 20 days. Okay. Okay, how many of you have not understood the process of naming? Please let me know. What is the logic behind using the name It is random or logical. So the countries, they give these names, they submit these names. India has submitted 13 names, Bangladesh has submitted 13 names, Iran has submitted 13 names, Pakistan has submitted 13 names, Myanmar has submitted its own 13 names. So all those names that they have put, it is put in front of the country name, and one by one from that list it is picked up. Okay. And Akshay, if Tej will come from Arabian Sea, then why would it be called as Hamoon? Okay, so let me know any of you who have also not understood the process of naming that. What is the process of naming the cyclone? More dangerous is tropical cyclone, Pooja. It has more destruction. Okay, Akshay, understand this process. Listen to this carefully. If you have Indian coastline like this, right now there is a cyclonic formation happening here. This is declared as Tej. Okay. Whether this cyclones come here, whether this cyclone goes here, whether this cyclone goes here, whether this cyclone goes here, anywhere, it will be named as Tej. But does not mean there won't be any other cyclone. Does that mean that this is the last cyclone ever to have happened in northern Indian Ocean? No. There can be occurrence of another cyclone here 5 days, 10 days from now. When that cyclone will get created after this, it will be named Hamoon. Why? Because the name Tej has already been utilized. So the next cyclone which will get created will be Hamoon. Whether the cyclone will hit here, whether it will hit here, whether it will hit here, anywhere, it will be named as Hamoon. After some time, let's suppose after a couple of months, another cyclone gets created. Another cyclone, when it gets created, it will be not named as Hamoon anymore. It will be named as Midhili, because that is the name next on the list. One by one, a name from the list is picked up and the cyclones are named. So it is not the case that Tej will be named as Hamoon, Tej will be named as Midhili. Is that understood? Are you getting the grasp of it? If not, please ensure that you ask the question. Nikhil, that is true. Very correct. So first left side will only occur, or both can occur from. So first left side will only occur, or both can occur from either of the ends. Okay. Left side as in, please talk in the, are you talking about Arabian Sea and Bay of Bengal? See, why does a tropical cyclone get created? Due to low pressure. At the same time, you can have simultaneous occurrence of low pressure both in the region of Arabian Sea, and within a few moments or within a few days, you can have a simultaneous occurrence of the cyclone in other region also. For example, when you had Cyclone Tote was formed in the region of Arabian Sea. It hit the Gujarat coastline, it hit the Maharashtra coastline, causing a lot of destruction there. But immediately, while that cyclone Tote was making the landfall, cyclone Yas got created in the Bay of Bengal region. So the next cyclone which gets created will be named as Yas, right? So I think your question is something different. I'm not able to understand your question from the doubts that you are pasting. Please encapsulate. Okay. These lists are repeated or not? No, they come up with a new list. Once this list gets over, the countries will come up with a new list. Parshuram, cyclones can happen multiple times at the same place? Absolutely, yes. Priya, does it mean the country whomsoever RSMC center first detect the cyclone, give it the name from their list? No. No, this list is there. This list is, it is not as if India has detected first, India will start giving its own name. That is not the case. Please understand, all the countries which are impacted by the tropical cyclones, let us talk only about the northern Indian Ocean. So when we talk about only the northern Indian Ocean, for all the countries situated here in the northern Indian Ocean, the RSMC, that is the Regional Specialized Meteorological Center for all these countries, is at New Delhi. Okay, so once the tropical cyclone warning centers in the region or in the surrounding areas, when they give the warning, the naming will be done by the RSMC New Delhi. Whether there is a cyclone forming in Arabian Sea, whether there is a cyclone forming in Bay of Bengal, the naming will be done by RSMC, which is situated in New Delhi. Does not mean that the government of India has got a sovereign right about the naming. So how is that naming done? Naming is done from a list. What is that list? So list is where all the 13 countries, each of them have given the 13 names, each of them. So if you think about it, you have 13 countries, right? Bangladesh, India, Maldives, right? Or Iran before that, Myanmar. All these countries, they have, these are your 13 countries. They have given 13 names. So first name, second name, third name, fourth name, all of them have given 13 names. Okay, and so on, right? Now, here the cyclone is picked up, the list is picked up from here. First cyclone which will occur will be named. Then the next cyclone which will occur will be from the name given by India. Third one, name given by Iran. Fourth one, name given by Maldives. Fifth one, name given by Myanmar. Sixth one, name given by Pakistan. Name given by Oman. Like that, you will have the naming which is done. That is what you also observe in this, where again, if you notice carefully, you will observe. Okay, but sir, you said that Myanmar gave the name. So Tote is a name given by Myanmar. Michong is a name given by Myanmar. Like that, Myanmar has given many of the names, isn't it? Gati is a name given by India. Tej is a name given by India. So it is these countries who have submitted these names which have made it to the list. So the next cyclone which will occur, this cyclone is named as Tej. Next cyclone which will occur will be definitely named as Hamoon. And that Hamoon is a name given by which country? Hamoon is a name given by Iran, right? But is it the case that Iran's meteorological department will give that name? No, it is the name which is already submitted in that list. That list is already present before the RSMC. The RSMC simply picks up the next name on the list, regardless of whichever country has given it. RSMC simply picks up the name from that list and gives that name. Is that understood? RSMC is Regional Specialized Meteorological Center. These are your RSMCs. It means this list is not from 1999, my dear friend Tulsi. This list is from 2020 is when it has started coming into action. 2020 April and May was when when Ampan, that was the last name in that list. That is when it hit. After that, the new naming is followed. It means the when the countries from the name from column 1 empties, then we continue from column 2. Absolutely, yes. When the name from column 2 will end, then you will begin from column 3. The name from column 3 will end, you will begin from column 4. And that is how you will enter and go to column 13. And when that will end, you will need a new list. That is when the countries will come together to furnish a new list. Is it understood? Is it possible that two or more cyclones can occur at the same time but different places in India? Why not? Absolutely yes. Absolutely yes, it can happen. What type of question be expected on cyclone naming? How is it that the cyclones are named? As simple as that. That question has been asked in the exam twice in the mains exam. And I had a very interesting question, which, and it was a question from Kumari. Is it necessary to remember all the 169 names? So, if I were to tell you that it is important or essential to remember 169 names, would you start learning the 169 names? How many of you would begin learning the 169 names if I simply say in the class that you need to learn these 169 names? And would you be able to recall those 169 names? We are not talking about some random names here. We are talking about some very unique kind of names. So it is not only me, anyone from your friend circle, from your family, from your faculties, it can be me as well. Anyone, if they give you this kind of a suggestion that learn all of this, never do that. Okay, apply your logic in that case. I have many students who come up to me, and almost I cannot tell you the number of mails that I get on a daily basis on this query, that uh, how do we learn the names of all the national parks and wildlife sanctuaries? Now I ask them, who told you this, that you need to learn that? So my friend told, my senior told, my parents told, my faculty told me. Whosoever tells you or gives you these kinds of suggestions, first of all, stop all the contact from them. They obviously don't want you to clear the examination, and it is not at all required. Think about a question that you can frame whereby you would be required to name all those 169 names. What will be the question like? Will the question be like, what are all the names for which the cyclones have occurred since 2020 onwards and which will occur till 2030? Give and produce all those names. You won't be able to frame a question like that. Okay. So for a particular, and understand, think about it, understand the pattern and the thinking of UPSC. Do you need to learn the name of the cyclone which has occurred immediately? While you will cover it in current affairs. But think about it. How will UPSC ask that question? Which was the cyclone which was observed recently in Arabian Sea? UPSC is smart enough to know that by the time that it has set the question paper and the time that you are appearing for the examination, the prelims examination, in the meanwhile, there is a 1 month time interval. So it can absolutely happen that in 1 month, there can be a new cyclone which would have happened. And the answer would be incorrect in that case. So UPSC will never ask you these kind of questions. I will show you the kind of question which was asked. Please understand. Please don't follow such kind of suggestions. Okay, it is not something that you need to be apologetic for. It is simply something that you need to be aware of. Beware, because in the preparation journey you will find many of these kind of suggestions. Never do that. I will show you the kind of a question. So this is a question which was asked. Look at the third question. The question which was asked in 2014, I guess. So 2013. The recent cyclone on the east coast of India was called Phelan. This is from the older list. How are the tropical cyclones named across the world? Right? Even last year in the mains examination, there was a question. What is the process of naming of the tropical cyclone? So that is something which you have to attack. Okay? Ancient history can Lala, in fact, for that matter, I have always maintained that remembering the names of ancient history is much simpler. Art and culture is a bit tough. Ancient history is still simpler. But if you are tasked about remembering let's suppose, all the wildlife sanctuaries, try doing this and still giving a meaningful attempt next year. It will be impossible a task. So that is something you have to be very, very well aware of. Now, effect of air masses on the climate. So air masses, in their own sense, will significantly end up influencing the regional climate. So they will have the impact on temperature. Obviously, Cold air mass will reduce the temperature. Warm air mass increase the temperature, isn't it? So cold air mass, reduction of temperature. Warmer air mass, increase of temperature. Then they will also lead to precipitation. How? So wherever you have maritime air mass becoming onshore, air mass becoming onshore, it will bring substantial amount of rainfall. But in what other condition can the air mass bring rainfall? Maritime air mass being part of the onshore wind will bring you rainfall. But in what other condition will you experience rainfall? Let me see. Cooling, yes, Bravi, you are in the correct direction. Basically, correct. Very good. It will be when you have these air masses forming fronts. The cold and the warm fronts, they will also lead to existence of precipitation, creation of fronts. Cold front as well as warm front. Okay. And then basically front, we have already talked about that they can influence the climate in that region, inversion, thunder, lightning, and the air masses will also lead to occurrence of cyclones. So if you have a detailed question of 15 marks that talk about the impact of air masses on the regional climate, will you be able to explain it or will you find any difficulty? Let me tell you what you need to write in that. So first of all, in that question, or let me show you the question as well. Discuss the concept of air mass and explain its role in macroclimatic changes. So here in this, in the introduction, you have to talk about the basic definition of air mass that you have seen in the PPT itself, in the first slide. Then very briefly, you have to talk about source regions, give certain examples. And then in the body part itself, you have to start expanding about the air masses and its impact. So talk about advection, talk about precipitation, advection in the sense that it can influence the climate, the temperature of an area. It can increase the temperature, it can decrease the temperature of an area, isn't it? Then when we talk about, let's suppose the precipitation, so, and write these in bulleted points, right? Wherever possible, draw a schematic diagram. For example, now many of you, when I take a look at the answers that you have written, you don't draw enough diagrams. And then you have the query that in this, what kind of diagram was required? Let me tell you what kind of diagram is required. Diagrams, they depict much more than what you have written. So for example, when you talk about precipitation, maritime air mass becoming onshore, so show a simple image like this. This is sea, you have maritime air mass, right, reaching the shore, forming clouds, causing rainfall. That's it. It has taken around 40 seconds. In that 40 seconds, you can do this diagram, right? So get into the habit of this. For example, frontal formation, immediately do this. Warm air, cold air, right? Here you have formation of clouds, occurrence of rainfall. So all of this, these small little images, they should supplement what you have written, so that in case something that you have written is not very clear, not all of us have a kind of a good English. So in that case, I have seen many of your copies, the language skill is lacking quite significantly. So there you will improve slowly, but you can make up for it by depicting in diagrams. Okay, so when you depict it in diagrams, it becomes much more easier. Okay. Now, tropical cyclones are largely confined to South China Sea, Bay of Bengal, and Gulf of Mexico. Why? So, for this, I would want you to compile the reasons from the portion of climatology as well as oceanography. So, keep this question. We will discuss it later after the module 14. That is when we will discuss this. The recent cyclone and all the meanwhile, the remaining modules that we will be covering, all the meanwhile, we will be continuously adding points to this question that why Bay of Bengal experiences more cyclones, tropical cyclones, obviously, as compared to Arabian Sea. Slowly and steadily, we'll be adding on to the points. By the time that we reach the end of 14th module, you will be in a good place to answer. The recent cyclone on the east coast of India was called Phylon. How are the tropical cyclones named across the world? Let's suppose this is a 2014 or 2013 question. Let's suppose you have a newer question, and a newer question in the sense simply talking about how is it that they are named across the world. Now, how do you answer that? So first of all, in the intro you talk about that the naming of the cyclone is an absolute must in order for scientific identification and also for a greater public recall, which is required to save maximum number of lives and property. That's it. That will be your intro, why naming is there. Then talk about the fact that naming is done with the help of multiple agencies, including the TCWC, that is the Tropical Cyclone Warning Center, and the regional specialized meteorological centers. Whenever and immediately when a low pressure is detected, then and where the probability of formation of a tropical cyclone is imminent, then the TCWC warns the RSMC of that area. Across the world, you have 6 different RSMCs, with RSMCs located in New Delhi for the Northern Indian Ocean, located in Reunion Islands for the Southern Indian Ocean, located in the region of Tokyo for the typhoons in the region of the Pacific, Honolulu, Nadi, as well as Miami. So these are your various different RSMCs. Now, RSMCs, when they receive the information of a cyclone, possibility of a cyclone developing in the region, after that, they follow it up and they pick a name from a list which has already been submitted to them. In the case of Northern Indian Ocean, basically, it is the list which has been submitted by a group of 13 countries, each of them having given 13 names, making it a total of 169 names. The countries are arranged in an alphabetical order and in a row manner, and the names given by them are arranged in the rows in front of them. You can show a simple diagrammatic representation, a very rough diagram, somewhat like this, where you talk about the country, simply write the country, you talk about the names. So 1, 2, like that, talk about 13. So countries, talk about the first, Bangladesh, talk about the last, that is Yemen, right? And the names are given. So one by one, the name is picked off. Any of these cyclonic names which would have caused maximum amount of destruction and devastation, a lot of deaths, that name is marked off, is ticked off, never to be used ever again. When this naming gets or the list is about to get over, then the countries they would come together to furnish a new name, as was done earlier when you had 8 countries submitting the names, that is the 64 names in the Northern Indian Ocean. The last name on that list was Cyclone Ampan, which hit the coastline, Bengal coastline, in April and May of 2020. But having said that, even the previous name, you don't have to mention it. The previous, that is Cyclone Ampan, you don't have to mention it. You simply have to talk about the naming. Now, if a cyclone occurs in Bay of Bengal or Arabian Sea, anywhere in the Northern Indian Ocean, a name is picked up from the list and is utilized. Like that, you can answer that. Okay? Is that understood? Or do we have doubts in that? Utsav, it was your question. So I hope that it is understood. Good. Now, bring out the causes for the formation of heat islands in the urban habitat of the world. You would be able to tackle this. This is a question that I had given to you even in the weekly test in case you guys are writing about it. So the formation of heat islands in the urban areas. So what are these urban islands? That is something that you have to talk in the intro itself, right? The brief diagram will be required. Again, Why I am stressing so much on diagram is that you guys are not doing particular, many of you guys are not doing particularly well when it comes to representation of diagram. Diagram representation is very, very easy in these cases. You don't need to be very accurate with the diagrams. Just a simple and a mere representation would be more than sufficient. Okay. A mere simple representation would be sufficient. So here you talk about the temperature, how it rises and it falls. Mark here temperature. Mark here rural, urban, semi-urban, rural. Okay. So whenever you do this, whenever you bring the diagrams into, now again, few of you go overboard. You start using the glitter pens, red pen, blue pen, black pen, green pen. It is so very apparent that you have spent half an hour on the diagram. That is something you will not be able to do in the exam hall. So be very professional, a rough diagram, which should be clear in terms of what is the message that it is giving out. Okay. Now, what do you understand by the phenomena of temperature inversion in meteorology? That again, I hope is clear. Now, how does it affect the weather and habitants of that place? So temperature inversion, you know that it can create the lack of mixing of air. Cold, it can bring to a halt any process of convection whatsoever. All these patterns you can talk about. Okay, no visibility, yes. For a good answer, around how many diagrams? Ideally minimum of 1 to 2, depending upon the demand of the question. To see, in certain questions, in certain answers, you will have the scope to bring 3 to 4 diagrams. For example, if I have a question such as the geophysical characteristic of the circum-Pacific zone, you have the scope to create 3 diagrams. First diagram will be for the circum-Pacific zone. Second diagram, oceanic convergence. Third diagram, oceanic continental convergence. Right? So in these answers, you have the scope to create multiple ones of them. For example, factors impacting the climate of India. You can present at least 4 to 5 diagrams. So diagram should not occupy the whole of your page. It should be in a restricted portion. In mains, diagram is necessary even on temperature inversion. Yes, my dear friend, understand. Please don't think about it that if I draw the diagram, why will I draw the diagram? Won't the evaluator understand it on his own or on her own? They are smarter than you guys. But think about it. Put yourself in the position where everybody has written the similar kind of answer in the mains. They have gone through the similar kind of study material. So after a point of time, you won't read beyond 2 to 3 answers, right? We had an interaction that we conducted with the professors who earlier had evaluated the civil services answer copies. Now many of them said that we don't read beyond first answer. It is the first answer where we make up our mind about the candidate, and after that first answer, if the answer is very good, then we go to the second answer. Otherwise, after that, we just glance through. Pages are filled. We put in average or above average or below average, depending upon the first answer. So you have to provide an incentive for the evaluator that go through my copy. I have written the content. How do you provide that incentive? By making your answer much more appealing. How? Content alongside that, draw the relevant diagram so that the diagram should catch their eye, right? So that they are bound to. Now it should, if it is an absolutely rubbish and incorrect diagram, it will do the exact opposite of what it is intended to do. Okay. Yes, Nikhil, images are mightier than words. Madhuri, in mains, diagram is necessary. If not in mains, then where else will you draw the? Will you start drawing the diagram in the interview? That, okay, sir, this is a nice question. Let me draw a diagram and explain to you. In the prelims, you have an OMR sheet. Where will you draw the diagram there? Obviously, we are talking about the mains. Understand, and I will tell you with a certain amount of confidence that we have gone through multiple thousands of copies till now in my career and in our experience. Trust me, in general, I have observed those answers are rewarded much more wherever you have diagrammatic representation, flow chart, block images which are there, you won't believe. But if you look at few of the copies who eventually turn out to be the toppers, you will find that they bring diagram even in the subject of polity. My dear friend, I'm talking about the subject of geography here. Think about it. In polity, what kind of diagram will you draw? Will you draw the parliament there? The new parliament is like this. No, they use it for the block representation. That is how they make their answers appealing. So you are in a competition. And remember one thing, around 9,000 to 10,000 people, depending upon the vacancy that year, they will be appearing for the mains examination. They would have, on the minimum, read the same number of books as you have, if not more. So, in that 9,000 to 10,000, you have to get amongst the top 500 to 600, in the sense that your mains mark should be such that you easily get through the merit list. So, how do you get through that amongst everybody who has read the same books? It is by your writing skill, it is by your representative skill. That is how the personality of the individual is checked. In the exam, in the mains exam, nobody knows your name, nobody knows your background. Whatever you have written is being judged. So keep that in mind when you frame your answer next time. Block diagram is basically a kind of a flow chart. So, for example, factors or the discretionary power of the governor. When you do this, you basically make it easier to read, you make it easier to comprehend as well. Isn't it that is wrong judging someone from the first answer? Absolutely yes. Absolutely yes. But then the world is not perfect, my dear friend. So that is the case. And let me also tell you that when you write the essay paper, rarely will have I come across an evaluator who goes through the entire essay. Right? Rarely, very rare. Out there in the exam hall, the mains exam, rarely. They will make the judgment based upon the first couple of pages, and they will mark you, give you the score out of 125. So that is how it is. But that is the competition that everybody goes through. You have to get through that competition. Okay? I hope that is understood. Now we come to the portion of atmospheric phenomena. Now, atmospheric phenomena, so we can save our time by writing good in starting only. What if you get an evaluator who checks all the copies, all the answers? Then what? What if your answer copy is in the top of the list that they have opened up early morning? Then what? That they will find out that the rest of the answers are subpar. Then what will you do? You do your best, whatever you can do. Rest, leave it to the process. The process will take. But I have never come across a candidate who is very well deserving and continuously he has been scoring very poorly in the mains. No. Deserving candidates who know the content, who know how to write answers, whose English is fair enough, not very bad, it is good, they get through. Okay, all that they do is write 20 answers, average 20 answers, above average 4 to 5 out of them, but all the rest is average, slightly beyond average. They get through the mains. So you do your work, you will get through it. Don't worry. Now, when we come to the portion of atmospheric phenomena, here we discuss certain important concepts such as Walker circulation. We talk about El Nino, La Nina, what they are. We talk about Indian Ocean dipole, Madden-Julian oscillation, and jet streams in this entire process. Now, these atmospheric phenomena are quite complex. Many of them are something that you won't find in your reference books as well. For example, IOD, MJO, etc. You generally don't find it in your reference books. Many of them are not very well understood. Till now, we have not understood that phenomena significantly. For example, in jet streams also, you have many of the factors which are still unknown, which are still being worked upon. In MJO, Madden-Julian oscillation, you still have, as we speak, you have a team from NASA and the basic NOAA, that is National Oceanic and Atmospheric Administration that you have in United States. They are basically trying to form a linkage between MJO and El Nino and La Nina cycle. So not all of these factors are perfectly well understood, but we have enough idea to gauge an influence that they will they will subtend on the Indian climate, the Indian monsoon. So that is where it becomes relevant for your examination, its role in India and Indian climate. So for your prelims, what is the portion which is very important and is relevant in your prelims? Here, basically, Walker cell, Walker circulation, Enzo cycle, that is the basic of it. Okay, then after that, jet streams, Indian Ocean dipole. For your mains, Enzo cycle and Walker cell, then jet streams. These are the ones relevant for your mains examination. MJO, if there is a probability of it being asked, it will be asked in the prelims. Okay, MJO, if there's a probability, very basic. As per DNA, El Nino and La Nina are not going as planned. Then how do we make it correct to predict weather? Better scientific readings that we have, we still don't have a perfect understanding about the why is it and how is it that the El Nino conditions are repeated, how is it that they intensify. So more research is required. Okay, so we start with the Walker circulation and we will slowly and steadily move towards all the other concepts. One by one we'll pick it up. So we start first of all with the very basics about the rise and the principles involved in the rise and fall of air. So till now, while we were studying about the local winds and the permanent wind systems, we had seen that across the planet, you have various different regions where the air rises up, falls down, right? So in the portion of the planet that we have observed, what have we observed in general? We have observed that around the region of equator, air rises up, isn't it? It diverges, sinks. So basically, what we have observed is a kind of a rise and fall of air happening across various different latitudes. That is from 0 degree, maybe 30 degree, 30 degree to 60 degree, be it that heating or cooling. So rise and fall of air is happening at different latitudes, right? Now, in the case when we talk about certain areas such as, let's suppose, the vast Pacific Ocean. Now, Pacific Ocean is so very large and so very vast, especially in the central portion, that different parts of the Pacific obviously can get heated at different rate. You can have the eastern portion of the Pacific becoming much more hotter as compared to the western portion of Pacific, right? So that can always be in existence. So when you have that situation where one end of the Pacific, let's suppose, is much more heated than the other end of the Pacific, what will happen? In that case, if this is the latitude, then across the same latitude, one end will be hotter, one end will be colder. So we will have a circulation across the similar latitude also. We can have the same latitude also, we can have a circulation. That is something which happens across the Pacific. And for the first time, it was detected by one of the greatest climatologists in the late 19th century and the early 1900s, that is the early part of 20th century, Sir Gilbert Walker. Now, Gilbert Walker was a meteorologist par excellence. He rose up the ranks very, very quickly. Now, Gilbert Walker was absolutely convinced that both ends of the Pacific around equator, they will not have the same temperature. They will end up indicating different temperature that they would have gained in the process or lost in the process. Now, what that basically turns out is the fact that when you have different temperatures across the Pacific, maybe western portion is heated up or eastern portion is heated up, you can have a circulation at two ends of the Pacific itself. You need not go to different latitudes for a circulation. Circulation will be in existence there itself. Now, what does that mean? That it is a longitudinal circulation across different longitudes but at the same latitude. Now, Gilbert Walker was absolutely convinced that this circulation which is happening in Pacific would not always only be restricted to the Pacific. It would also be present in the region of Indian Ocean. It would also be present in the other parts of the world. And definitely it would be impacting the Indian monsoon. It is because of that, in order to find that much more and greater detail of that, that Gilbert Walker came to Indian Meteorological Department. Later on, in the early 1900s, he rose as the head of the meteorological department as well. He became the head of the Indian Meteorological Department for quite some time, right? So, but then at that point of time, he did not come up with any new findings anymore. So, based upon Gilbert Walker's finding in the Pacific, that is why it is named as the Walker circulation or the Walker cell. Let us try to understand what it is. So first of all, let us try to understand with the help of the image, and then we will observe the written text as well. So first of all, and pay absolute attention here. Let's suppose this is your equator. Let's suppose this is the equator. Now around equator, we have the permanent wind system which is in existence. Which is that permanent wind system? The trade winds, isn't it? And how is it that the trade winds, they move? Trade winds move like this. Now, if I were to, let's suppose, erase this portion and think about only the equatorial area, the direction of the trade winds is in general which direction? East to west. Now, before developing on this concept, I will take you back for a few moments. And here, let us talk about oceanic water, because Pacific is an ocean. So when we talk about an oceanic water, here, now, let's suppose we have land areas on both sides and think of it as a larger ocean. You have land, and ocean. Now, the prime source, when we talk about the heating of the ocean, especially in the tropical area, the prime source of heating of ocean is what? Where does the ocean receive its prime heat from? Perfect. From the sun. So sun is that source of heat. So when the sun is that source of heat, means what? Means the ocean temperature, this will be the hottest layer. And as you go lower, it will get cooler. Make sense till now? Now, suppose there is a very strong wind blowing in this direction. Let's suppose there's a very strong wind moving in this direction. Now, as the wind is in motion, as the wind blows, it would be fair to assume that some amount of surface water it will drag along with it, very little amount, but it will drag along with it some amount of surface water, isn't it? Here also, as the wind is in motion, it is fair enough to assume that it will drag some amount of surface water along with it. Now think about it and apply logic here again. Surface water which was present here has been dragged away. That means in this area, in this particular region, where the surface water has been dragged away, only two things can happen. Either the water level goes down in that area, or it is replaced by the subsurface water coming from underneath. Only these two things can happen. Subsurface water can end up replacing that. Obviously, water level is not going to go down substantially because of the wind. So the subsurface water replaces the removed water from the top. Now the subsurface water is cooler, always, because it is receiving lesser amount of sunshine. So subsurface water is cooler. So in a way, if the wind is moving in an offshore manner, it will lead to water coming from the lower regions close to the surface. That is what is referred to as upwelling, because the water is going up. So this is what is upwelling. Meanwhile, on the other side of the ocean, all these winds, they are carrying the surface water along with them. All these winds, they are carrying the surface water. So I can say that on the other extremity, all the surface water which was carried will accumulate here, will start accumulating here. Now this water which is getting accumulated, will its temperature be high or will its temperature be low? What do you think? Correct? Temperature will be high. Why? Because it is the accumulated surface water. Surface water is hot. So here the accumulated water that you have, it will be warmer water of higher temperature, right? Now, as the winds keep on blowing, they keep on bringing more water. So again, only two things can happen. Either the water can get pushed down eventually, or these can flood the land and the continents perpetually. Obviously, they won't be flooding the land. These are not so strong a wind that they will simply flood the land. So here you will have accumulation of that warm water. Some amount of that warm water will be pushed down. So because the water is getting pushed down, that is referred to as downwelling. I will give you the definition and the image of it separately as well. So don't panic, don't worry about it. So as the winds blow across the ocean, in one area, they have brought about colder subsurface water. Here you have cold temperature. Why? Because as the top layer has been taken away by the wind, the subsurface cooler water gets exposed. So on one hand, you have the colder water. On the other hand, you have warmer water due to downwelling. Right? Now, replicate this across the region of the Pacific and observe what happens. Now, in the region of Pacific, if I talk about the South American coastline, South American coastline is where you observe the trade winds basically moving offshore. The direction of the wind movement is east to west. So can I say that in the region of western portion of South America, that is the Eastern Pacific overall, can I say that here there will be significant amount of upwelling? Will that be a correct assumption or an incorrect assumption? Please let me know. Can we say that here there will be upwelling across the region of South America? Correct? Good. Why? Because the wind is carrying the surface water along with it in its direction. So here there will be upwelling. Upwelling means the colder subsurface water gets exposed. Colder subsurface water is exposed. Meanwhile, all these winds, they are moving from the region of east to west. So they will be accumulating all the warm surface water that they have brought about. So all that warm subsurface water, can I say, they will get accumulated here in this area. Right? Warm subsurface water will get accumulated here. So here you have warm water, warmer water accumulated by the wind. Now, one end of the Pacific, western portion of Pacific, you have warm water which is accumulated, means higher temperature. On the eastern part of Pacific, you have cold water which is exposed, means lower temperature. Warmer temperature is associated with low pressure. Colder water or colder temperature is associated with high pressure. So you have a comparative low pressure, a comparative high pressure which gets created. Clear? Now, winds always blow from a high to a low. So the winds, that is the trade winds, they will get strengthened. More winds will come into existence. So more winds basically will start blowing. And here, this will attract winds from all directions. The winds will rise up. It is not moving towards Japan. Please don't get that confusion that the sir has said in the class that the wind will go towards Japan. No, it is basically rising up. It will rise up, hit the region of the troposphere, the top of the troposphere. They will diverge around this area of the cold air. Already cold region means the cold air above. So there is a sinking tendency in this area, which will create a kind of a vacancy here. So that means winds will be supplied here. So what is this circulation? This circulation that you observe is happening across the same latitude, right? Unlike the circulation systems that we studied earlier between different latitudes, this is happening at the same latitude. And it is happening because the amount of temperature observed in the western part of Pacific is different from the temperature that is observed in eastern part of Pacific. And why is that the case? Aided by solar insolation, which heats up the surface, and brought forward by the trade winds, which drags that warm surface water, and that brings about this circulation. So this circulation, which happens across the east and the western portion of the Pacific Ocean, which brings about a low pressure and a high pressure, that is what is a Walker cell or a Walker circulation. Okay, so observe the cross-sectional representative diagram. So here you have trade winds which are in motion. Now this is the fair WX. WX here refers to weather. So wherever you have high pressure, you have fair weather. Sinking air means no cloud formation, dry condition, right? So Peruvian coastline is dry. And observe, as the winds take away the warm water, cold water starts rising up, lowering the temperature, creating that high pressure. All that accumulates across the Australian coastline. Observe here. This is your Australia, accumulates around the Australian coastline. And here you have the warm water and the air rising up. So air, as it rises up, it will form convective clouds, brings heavy rainfall around this region of low pressure. So here at the Darwin coastline, Darwin is basically around that area. So it will bring heavy rainfall. And that is what you have as a Walker circulation. Okay, I hope that is understood. Now, then trade winds blow from a general direction of east to west. The winds blowing over the vast expanse of the Pacific gain a higher speed because over water body, generally the wind motion is much faster. They have lesser or the least amount of resistance. So they move with a very high speed. These trade winds tend to drag some amount of surface water along with them. These surface waters are warmer due to solar insolation. Always surface water is warmer, lower level water is colder, right? Especially in the tropical regions. So they will be dragged. The warmer water will accumulate, that creates a low pressure. And meanwhile, in that area of where the upwelling has happened, there will be a higher pressure due to colder water getting exposed. Okay, so that circulation which is initiated, that is a Walker cell. It is a longitudinal, that is east to west circulation across the equatorial Pacific. That is known as Walker cell or Walker circulation. It will bring significant amount of rainfall across the Australian coastline, across Indonesia as well, in those island regions, and across the coastline of Peru or the South American coastline. It will bring very dry conditions. Because of high pressure, you will not have any cloud formation. You will observe dry conditions. Tahiti is in Central Pacific. Look at it. It is Tahiti is there in the Polynesian region. Okay, is that understood? Mira, cold water is heavy, so it is subside in the water. Then how can wind carry colder water? Mira, understand one thing. Cold water is heavy, but when cold water is at top, so then over a period of time, it gets heated by the sun, solar insolation, so it becomes warmer as well, right? It becomes warmer, so it is carried by the wind. But nonetheless, even if it would have been colder water, if the wind is very strong enough, won't it be able to carry some amount of surface water? I will show you one of the images that we will cover tomorrow, and that is of La Nina. Observe here. Cold water has come absolutely to the top. But if the wind is going to move, it will carry some amount of cold water along with that. Okay, it is not the case that the cold water, because it is heavy, it will not reach here, it will start sinking from here itself. That no, we cannot rise to the top. No. When it is risen to the top, it will get heated up. It will get exposed, it will get heated up. Okay. I hope that is understood. Even during El Nino, uh, thermocline line is shallower in eastern Pacific. As compared to what, Ravi? As compared to what? When we talk about El Nino, it is not as if, see, depending upon the heat, El Nino is referred to as a warming of the Pacific. So, depending upon what is the extent of that warming, because I'll come to El Nino tomorrow. So, that thermocline, that is supported by the wind motion also. And during the time of the El Nino, you don't have that strong a wind movement as is observed during maybe a La Nina event. So that is why the thermocline is not as deep as you observe in the case of La Nina in the Western Pacific. Okay, right? And is that process will reverse towards Peru region? Shilpa, which particular process? The upwelling or the downwelling? Which portion? Okay. Any other doubts that we have in the meanwhile? Please do let me know. Because I'm assuming that till this portion it is understood, so that we build upon this from tomorrow. And tomorrow we will jump to La Nina, El Nino circulations in an ocean dipole. Okay. So towards the Peruvian region, Shilpa, what happens is that because you have the wind movement, the trade winds, they are generally in the direction. This is the direction of the trade winds. So the trade winds, they carry the surface water away from here. So that means in the Peruvian region, you have the subsurface water which gets exposed. And that is the reason for high pressure. But again, after substantial amount of some amount of time, even that water will get heated up, even that will be carried away, and then again the subsurface water gets exposed. Okay, So I hope that is understood, and that is where we'll end the session here today. Today's session overall, if you consider where we have started from and where we have ended, you can easily expect a couple of questions in the mains examination from this area. Okay, this is one of the favorite areas of UPSC. UPSC plays with this area a lot. Those of you appearing for the exam next year or year after that, please you cannot afford to relax in this case. What I would suggest is take a piece of paper. I know it has been very tiring. Take a piece of paper, write or simply draw the diagram about the formation of a tropical or a temperate cyclone, as simple as that, or a Walker circulation. Write about it. Write 50 words, 100 words. Don't write a complex answer. A simple 50 to 100 words to convey what you have understood. Trust me, at the end of the month or maybe after 2 months, you will basically be grateful that you have written this up. Okay. Tomorrow we meet. We talk about the most important portion in the entirety of your syllabus of geography. That is the portion of Indian monsoon. And then we will move over to the global climate, which will be a short endeavor where it is very theoretical overall. And then oceanography is what we will target after that. Okay. So that will be all from my side. See you again tomorrow. I hope fresh and early. Till that, take care of yourself. Have a good night's sleep. Goodbye. Thank you.